Hey guys, in this tutorial we're going to look at making a simple cube or box frame structure using the AFX tool. So I've got Creo open here. I'm first going to select my working directory. You should do this every time. So if you didn't select your working directory here, we started making new parts, it's going to put them at our default working directory, which I'm using the EV2 shortcut. Therefore, my default working directory is the EV2 CAD folder. So we don't want to fill that up with our random stuff. So I'm going to select Don's Tutorials as the folder to put all my parts in. Once that's done, I'm going to click New. Now we want to use the Framework tool. The Framework tool only works at the assembly level. So we work with assemblies and sub-assemblies instead of a part and then features of that part. So I need to create a new assembly. I'm going to give it a name. I'm going to call it box frame _2. I'm going to uncheck using the default template and I'm going to click OK. Then the template I want to use, it's already selected the new racing one for me. If it hadn't, I would click Browse on the left here, Working Directory, then upper folder into EV2 CAD, then the templates folder, and you see the .asm or assembly format or template there, and you would select that. So here, assembly number, so this is from our project codes, so I'm just going to put in 801, A801, which will be like miscellaneous or tires, one of the two, doesn't matter. I'm going to delete this once these are done. Assembly title, this is the title of the assembly. So we'll call it box frame, and then name. This is the author or designer's name. So I'll put my name here. Then we'll hit OK. And now we've got started. So the way that, there are many ways to do different things. The way that I have learnt to do things, and I think it's a pretty neat and clean process when you're making framework parts, is first I would put in all my datum planes. So these here in front of us are datum planes. First I'll put in all the datum planes for the things that I want to make. You know, say it was the chassis, I'd have the datum plane for each place where I want to put the points. So the front bulkhead, the main roll hoop, the front roll hoop, and the back. And then I would put in all my sketches, which contain lines and points in 2D, and they would all be in the same plane. So if I was to do it off this front datum plane, if I'm doing the chassis, they would all be in a line in the Z-axis here, translating. And once I've got all the 2D sketches, I would then create 3D sketches by using the datum plane, datum tool up here, datum curve, and I would select the points and draw curves. So we'll go through a sort of simplified version of that, and in a later tutorial I'll probably go through making the whole chassis. But so in general, we have to start with an assembly, then we put in our planes, then we put in our sketches, then we create our 3D sketches, so our datum curves, and then we switch over to using the framework tool up here and start putting in our members and notching them, or whatever it is that we require. So I'm going to start here by left clicking on, it doesn't matter which here, but I'm going to select the front one and I'm going to left click on it and I'm going to click plane, which will add in a datum plane. You could also have used the button up the top. I'm going to translate it 200 mil, this is arbitrary. I'm going to go over here to properties and I'm going to name it. It's really important for yourself when you want to go back through your model tree, but especially for other people to understand what you've done, to give your features in your model tree intrinsically named variable names. Like, give them a meaningful name. So here it's a little bit hard, but for example, if this was a part of the chassis, I might call this front roll hoop plane. But here I'm going to call it front box plane. Now in this field here, you don't actually need to put the underscores, but when you name things in Creo, you have to have underscores instead of spaces because the 90s. It's really frustrating, but that is one of the locations where you actually don't have to type them in, but you can see I've developed the habit. So thanks for that, Creo. So now I'm going to put a sketch on this plane, then I'm going to put a sketch here, and then I'll connect them up in 3D. So first I'll select this plane, the front plane, and I'll hit sketch. Just going to draw a rectangle. Actually, before I put that in, I'm going to put in 2 center lines, one on the horizontal and one on the vertical. Middle mouse to be finished with the tool. Put it away kind of thing. Then I'm going to select rectangle. I'm just going to draw a rectangle in. Going to hit the dimension tool, and because I've put those center lines in, I can select this edge, then I can hold control, I can select the center line and then the same edge again, middle mouse click, and that classic, select the thing, hold control, select the center line, select the other edge, middle mouse click, and it can't create it. Why can't it create it? I'm going to set these to be equal using the equal constraint. Constraints are your friend. You should dimension things to be constrained, not just a lot of extra dimensions. So you can see here, this is what I was trying to do. I don't know why it didn't work just before. But so I selected the top edge, then the center line, and then the top same edge again. And now it's saying, oh, you want to dimension something across that center line, sort of like equidistant, mirrored across the center line. So I'm going to type in 300. And now from here to here is 150 on each of the center lines. So I'm going to just try and put in, maybe I didn't put this center line in. Select the dimension tool, select the edge, hold control, select the center line, select the edge again, middle mouse click. Yeah, I mustn't have put the center line in before. I'll type 300. And because I set this side to be equal to this side using the equal tool by selecting it and then selecting the 2 lines or edges, they're now equal. So you can see now we have a square and it is sitting centered on our coordinate system there. Not required for anything, of course, but it's just the way we're doing it. So now we're going to put in the other side of our box. We'll select this datum plane, select sketch, and we're going to do the same thing. So our 2 center lines, making sure we put both in this time. Then we'll draw our rectangle, select our dimension tool, select the edge, hold control, select the center line, select the edge again, middle mouse click, enter our dimension. This one will make 500 mil. Then we've still got the dimension tool selected, so we're going to select this edge, hold control, select our center line, select the edge, middle mouse click, 500. And we're going to middle mouse click to get out of the dimension tool, and then we're going to select the equal constraint, going to select this edge and that edge, and it's telling us, hey, that's already a thing because you've got these. I'm going to delete the horizontal constraint and instead have the equal constraint. All right, so now we're finished with that. This option menu here lets you select some of your view options. So we can see some datum planes at the moment. If I were to untick plane display, we can't see them anymore. This option here shows annotations. There are currently no annotations here, but you might see those in the future. I'm going to turn those off, and I'm also going to turn off the coordinate system. And I typically work with most of these off. If I wanted to work with some points right now, I would probably have the points on, or you'll do it as you go. Whatever you want on, you'll set them all on. In your model tree, of course, you can hide certain things because you might end up with a model that has 50 planes and you only want to see 3. And this is a global setting. On the topic of intrinsically named variables, over here we didn't name our sketches, so we should have named these as well. So you can select them and then right click and rename, or the keyboard shortcut is F2. So I usually select them, press F2 and then give it a good name. So this will be front underscore box underscore sketch. There is a maximum character limit, but I typically, this is a plane, so I put plane in the end if I can fit it, or I shorten the front so I can put the word plane. Just helps to visually group them. You don't have to look at the symbols as much. This one we'll rename to, what do we call that plane? Oh, we call that one front. We'll call this sketch 1, super useless names, but for the video it'll work, and this will be sketch 2. All right. So you can see there's the select all function, which is how I usually quickly turn everything off with that setting. Now we're going to go to the framework tool. We're going to go create a new project, enter a project shortcut. So we'll call it box_frame. You can open up project parameters here, and I should make a more detailed video on this with some more preparation. But basically, when you create new framework members, it'll auto-generate part names for all the parts. It'll index the parts. So this is where you can set a prefix. So, you know, maybe I'll want the prefix to be orange, and then everything will start with the word orange, and we'll see how that plays out. You can set which parameters you want to inherit. There's some settings here that I'll make a video on in the future. But for now, we're just going to set orange. So then we're going to go new profile. We might actually do this in, no, we'll leave it as one large assembly. So this is where you select what cross-sectional profile you want for your frame members to be. So I'm just going to pause while that truck's there. All right, the truck is gone, sorry about that. So, I don't know what I was saying before, but it's probably something about, this is where we choose our cross-sectional tube profile. So we've got, you know, different units, millimeters, beams, a whole collections of cross-sections. You've also got sheet metal. I've had issues with sheet metal where you can't get them to notch. I don't really know much about the sheet metal tubes or cross sections. I don't know when it'd be more appropriate to use them. All my experience is using steel beams in millimeters. Now I assume just like strand 7, you can make your own cross sections and add those in. I did not investigate that, but it's something that should be looked into, and it's probably quite easy. So we go into steel beams, millimeters, and you can see a bunch of names and some visual examples to give you some context. So for our frame, we're just going to make it out of square tube. Now these are your standards, and they have sizes. Again, if there's something that you need and it's not here, you probably have to make a custom profile for that. We're going to choose Australian Square Hollow Section, or SHS, 25 by 1.6. So we've got some information up here, and you can see on the diagram there's a dimension B, and up here it says B is 25, and then another dimension T, which is 1.6. So that's the wall thickness. This is the outer dimensions of the square. So now it wants to know where we want to start putting the assemblies. We're just going to hit next. All right, now we're going to select these lines. You can see here we're selecting, our reference method is straight. It's a straight line. If you want to do something with bends in it, say a roll hoop, you need to pick this curved option. Otherwise, it won't generate frame members along the whole length of your sketch. And I'll probably show that error in the chassis tutorial. So anyway, we've put a frame member there. We're happy. We've got a bunch of options here. These are about the positioning. In this tutorial, I don't really want to get into the positioning too much, but it's very powerful. You can rotate them around and you can position them. So this positioning here is with reference to the edge or line or curve or edge that we've selected. So at the moment, you can see it's sitting central to the line. We could select this option here, for example, and now you see the line is in the top left-hand corner relative, and now it's in the top right, etc. You can also click this one here, which should reset it. Nope, this one, sorry. this one here, which will reset it. You can manually translate it a set amount in 2 directions using this option here. You can, there is the move tool up here, so you can come back and revisit this, but most of the time I would use the center. You'll want to pick a convention for how you're going to do all your frame members and then do them all that same way. You could also rotate it for this frame member. That doesn't really get us anywhere, but we're happy with where it is, so we're going to middle mouse click and that hits the repeat button down here, which says, yep, I'm happy with that, and I now want to put in another one of that same profile. If I wanted to change the profile, I would click up here, and now we can change the profiles here while we're creating them. If I wanted to change away from square hollow section, from square tube, I would have to close this and then go into new profile again and select the profile I wanted. But for this tutorial, we're just going to put some square tube here. So I'm just left clicking and middle mouse clicking. All right. And then we're going to also put some on our other sketch. Okay. And I'm just going to close that. So you can see we now have a bunch of framework members. They have, over on the left here, they have names. And they have information about them. They've all come up with this auto-generated box frame from the assembly name, and then square tube, and then 1 and 2 and 3, etc. So they've indexed there. This is really useful when you're trying to make drawings and you want to reference your parts. You can, use balloon references or something else to reference those numbers. Also, when you get tubes laser cut, the laser cutting company can etch all or part of those tube names onto your tubes for you. You can also do things like you could put in points that you want etched onto the outer dimensions for where to line tubes up. Some pretty fancy things like that that make the assembly process really nice. Getting back to this tutorial, you can see here our tubes, they're not notched and they're overlapping, and if you were to, to make this, it'd be impossible. It's not what we want. We want solid frames, and we also want to connect our members up from here to here. So we'll go to model, we'll go to datum, we'll add in a curve, and we're going to select the point there. Then we're going to hold control, and we're going to select the second point. Now we have a curve, and up here you've got 2 options, a sort of sine wave and an angled wave for straight lines. We want straight lines. If you don't do this, you can't put straight frame members on there. The framework tool complains at you. There is, as I've found, no quick way to make lots of datum curves. It's just a rinse and repeat process. So you could make a shortcut here. You could have a keyboard shortcut to datum curve, which would speed it up a little bit, but it's the same type of thing. We're going to come here, we're going to select point 1, point 2. Now you can, if your lines are all in a series, you can, maybe we'll experiment with that in a second, but you can make them all in one long chain. But when you put a framework member on it, it will probably, we'll test it out because I don't remember, it's been a while since I've done it, but it should say I'm not happy with that, and well, no. What it'll do is it'll make your whole chain of datum curves into one frame member, which you may want. So if you're thinking about it and that's what you want, that's all good, go ahead and do it. So I've made this curve here, and then I haven't clicked anything else, and I'm going to hold control. And in a minute, and select also this point here, and you can see it's now from there down to there. It's drawn a new line, and that's still on the straight line mode. And then we're going to come back. Just going to make something funky. So we're going to come back to this point. And the middle mouse click to get out of the tool. Alright, so we've got those. We're just going to now connect up our last bottom more regular curves. So again, the datum curve tool, selecting the point. And this would have been easier to do before I put the framework members in. Make sure you select angle, middle mouse click. When I say angle, I mean like straight line. When I made the chassis model, I did it by making these points here actual datum points, and that way they were easier to reference and you could measure off them, etc., things like that. Alright, so I've got those. We're going to go back to the framework tool up the top. We're going to go new profile. We're happy with that same profile. We're going to hit next. Just going to put some on our 3D members, so middle mouse clicking. Alright, and now our little experiment. That seems to be working. I'll just see if okay. Cool. Alright, so you can link them through in multiple chains, and it lets you put them together as separate frame members. So that is one way you can save time. Anyway, so as you can see, we've now got all the members in that we'd like, and none of them are notched. So we need to notch them or join them. So notching is when you take one tube and say this tube down here, we'll look at that surface, it's a good example. Say these two were connected at a miter joint, a 45-degree joint, and then we wanted to bring this tube in here and have it weld in as well. We would notch it, so cut out the material that's overlapping into the joint here, and we would get the sort of inverse of the shape that's left, and then that would let us butt it up nice and neat in there and then weld that up as if it was the one node. So that's notching. And now I'll show you how we do it. So you've got two options. You've got basic joints and advanced joints. In the basic joint options, very useful still, a whole heap of sections. So for example, these bottom faces, we want them to be miter joints. So we're going to select miter, and then you select the first profile and then the second profile. It'll generate something. If you're happy with what it's generated, then you can click repeat or middle mouse, which is default to repeat. So I'm going to go through and do that on all the desired miter joints. And on the top as well. All right. So you've got a couple other options here with joining profiles to ends, and pay attention to the 1 and the 2. That references the first member you select and the second member. But for these notches, I'm going to go to the advanced joints tool, where you can see we've got two main options that I used a lot: the cutout tool and planar trim. So the cutout tool is if you're making a complex notch shape like this connecting into that, I would use the cutout tool for that. So I'll show you how that works. Again, model to cut, select item 1. We want to notch this tube to suit these tubes, this join. So now the second tube we select, middle mouse, and now you can see it's cut this tube with respect to this tube, this frame member, but not this one. So make sure you remember to do all the associated tubes. So now again, we want to cut material from this tube also with reference to that tube. So now we middle mouse, and you can see that's cut that out. So if I get out of the tool here, if you want to check, you can always check easily by hiding your members, some or all as required, and you can see this has been notched to suit that. Again, because we're at the assembly level here, I could also check by left clicking on the member and opening it as a new part. This is actually really powerful, and it lets you create other features on this frame member. Say I wanted some holes drilled in it, I could now use the extrude tool and put holes in there. And I'll show that when I do a tutorial on making the cross brace. It just shows some more unique and interesting ways to use the framework tool. Anyway, we'll unhide that member by finding it in the model tree and selecting unhide. There are a few options here with hide and unhide. This one will hide show everything except for the tube highlighted, which is really great if you've got a big assembly and you have lots of parts that are hidden and you don't want to scroll through the tree finding them. You do that on one part, everything else will be shown, and then you unhide that one part, and then you'll have the whole tree back. So anyway, we're just going to go around and finish notching this up. This example maybe doesn't demonstrate it super clearly, but one interesting or important fact when you're making your notches is you want to notch things in the way that they're going to be built. Otherwise, when you go to assemble your shapes, you might not be able to actually assemble it. So I don't think there are any great examples here. Just something to be careful. You would need to notch this to suit that, and this as well to suit that one. Yeah, so no great examples I could show here, but if you think to the chassis, you'll often have tubes that go in as triangulating members, and if you don't notch them in an appropriate order, particularly when you have nodes with like 4 or 5 members coming together, you need to notch them appropriately. You might want, say we were triangulating on this member here, we were going to make a node here and we want to triangulate that. Maybe we were putting a cross brace in or something. You would leave this member as is and only notch it to the top corners, and then the member going through here, you would notch both. That would give you more strength and less cuts. So using the planar trim, just going to unselect anything. So planar trim is really great for when you want to notch something like this to another surface. So I'm going to notch it to that surface. Now I could do it to a datum plane, I could do it to a tube over here because they're at the same height, but I usually work from the area I'm working on. So then to notch it to this one, cut it there, I'm going to planar trim this to that, and that will just cut it to that plane. Because this and this are on the same plane, I know that I don't need to notch this again with a planar. Notch this one with a planar trim with reference to that, because it's already done it. So this one here is a really good example of using the cutout tool. And you can see there, we've only cut it out with this tube, so we're left with this kind of weird shape. If we hide that, we can see that the other tube, the other end of this, is still inside there. We still need to notch it. So advanced, select the cutout tool, and there you go. Alright, well that's just a basic tutorial on putting frame members in and creating joints. I guess while we're still on joints, I should finish up. If you want to delete a notch, you shouldn't delete the member. You should open up the joint tool, and then there's the delete option here to use. So the advanced joint tool deletes advanced joints. It's a little bit confusing like that. So there you go, middle mouse click, there's a joint here, middle mouse click, and now we're back to it. So then if you want to create joints again, the advanced joint tool, you need to select this option here. So I'm going to cut this one out with reference to that, try and prove a point. Basic joints, delete. I can't delete the advanced joint I just made, but I can delete these miter joints because they were made using the basic joint tool. So that's how you should delete joints. This delete up here would delete whole tubes, which is how you should delete tubes, because you can see in the tree here, if we go to part 9, this tube, When we create a framework member, we don't just create a new part, we also create datum curves, coordinate systems. There's a whole bunch of other stuff that gets put in here. And the correct way to delete that stuff, so the profile reference in that, would be to select the delete tool, delete the whole member. And that will remove it cleanly, instead of just selecting one part and then deleting. Alright, well, I think that's enough for this basic tutorial. In the next tutorial, I'll look to go over some of the more advanced functions over here, using some of these tools, the replace and modify and move tool, as well as editing a part and then replacing the geometry with that. Alright, I'll see you guys then.